Number 12, they want us to look at the following statements and determine what's true regarding sodium and chlorine. And you notice that they're talking about electronegativity of them, first ionization energy, which one has a larger atomic radius, all that sort of stuff. So let's see if we can summarize the trends by looking at the periodic table. So when we're doing multiple choice, we don't really need explanations, so the general trends should work pretty well. When we're comparing electronegativity, you remember as you go up and as you go to the right, electronegativity increases because fluorine actually has the highest electronegativity. So chlorine is more to the right than sodium is, so it's going to have the higher electronegativity. Chlorine's going to have the higher electronegativity, sodium's going to have the lower electronegativity. Alright, now let's look at first ionization energy. Ionization energy is how easy it is to remove an electron, so atoms that have high ionization energies are more difficult to remove electrons. So I think, again, chlorine is definitely going to be higher than sodium. Sodium, we know, likes to lose electrons. Chlorine likes to gain them, so chlorine is going to have a hard time losing them. So again, up and to the right is going to be the increase in trend. So chlorine will be higher, sodium will be lower. And then lastly, if we look at atomic radius, we remember that francium is the largest atom on the periodic table, helium is the smallest, and so as we go up and to the right, they're getting smaller. Chlorine is more to the right, so it's going to be little, and sodium is more to the left, it's going to be big. So sodium is going to be big, chlorine is going to be small. Let's look at our answer choices. Sodium has greater electronegativity. No, it does not. Sodium has a larger first ionization energy. No, it does not. Chlorine has a larger atomic radius. No, it does not. So it looks like D is going to be our answer. Chlorine has greater electronegativity. True. And larger first ionization energy. That's true as well. So D is the answer. Number 13, they have an atom of silicon in its ground state. It's subject to a frequency of light that's high enough to cause ejection. So it sounds like we're talking about photoelectron spectroscopy here. This is definitely a PES idea. An electron from which subshell would have the highest kinetic energy? Now before we look at these, you know, that's the quantum model idea. Let's just think about it in terms of a Bohr model. And I'm not going to draw out silicon. We're just going to compare electron number 1 here and electron number 2. The question is, which of the two of these would have the highest kinetic energy when it leaves the atom? And definitely the answer is 2. 2 would really be moving when it leaves the atom, because we're assuming they're being struck by the same amount of light, and it takes more energy to boost the inner electron out. And so when it actually gets out, it's going to be moving fairly slowly. So the outermost ones will be moving fastest. So all we got to do is figure out which orbital is the outermost one. Remember, the 1s is right here and right here. The 2p is right there, so that's higher in energy, because you remember, as we read across the periodic table, they're getting higher and higher energy. So 1s, isn't it? Let's see, the 3p is right here. It's even higher energy. And then we have the 4s, which is right there. So it looks like the answer is going to be D. 4s is the highest energy orbital, and therefore it will have the highest kinetic energy when the electron gets ejected. Number 14, they want to know if infrared radiation or ultraviolet radiation has more energy. And you remember that in our general electromagnetic spectrum, which I've drawn down here at the bottom, we have gamma rays on one side, which have the most energy, and we have radio waves, which have the least energy. And in the middle somewhere we have the visible spectrum. And you remember the visible spectrum is Roy G. Biv. And so red obviously is on the weaker end of things, so infrared will be just outside of the red part of the spectrum. That's why it's called infrared. And ultraviolet is ultra because it's just beyond the violet, which is sort of down here at the end. So UV is right there. So I'd say UV has the much higher energy because it's more towards gamma rays. So we can get rid of these two. Comes down to the reason why. Ultraviolet because it has higher frequency, ultraviolet because it has longer wavelength. And so I've drawn two waves over here. This one has longer wavelength. And you remember, the longer the wavelength, the weaker the energy. B doesn't look like it's going to be the correct answer. Frequency is how often the peaks pass a certain point, and of course this one's going to have very high frequency. so definitely the highest energy as well. So A should be the answer. In 15, they want us to find which of these isotopes has 3 more protons than neutrons. And so we can figure it out. They give us this very nice hint, which seems, I doubt the actual AP test would do this. Remember that the number before the symbol indicates the mass. Well, if we're going to figure out how many neutrons there are, remember we've got to subtract the mass minus the number of protons. So for boron, its mass may be 11, but its number of protons is 5. And so it's going to have 11 minus 5 is 6 neutrons. And of course it has just the 5 protons, so it does not have 3 more neutrons than protons, so that is not the answer. And that's essentially what we have to do to go through each one. Chlorine is mass 37, they said, and its atomic number is 17. If we subtract 37 minus 17, we get 20, and that's the number of neutrons. And of course there's just 17 protons, and that does look like 3 more, so I think that's going to be the correct answer.